For this project, I decided to measure the deflection in pieces of plywood measuring 8 inches long by 1 inch wide by 2/10 of an inch thick. The wood would be doubled up in each test. 3 tests would be conducted to measure which scenario had the least amount of deflection in it. In each scenario, the wooden beam would be loaded at the center with 3 masses. The first mass weighed 11.47 ounces, the second mass weighed 12.09 ounces, and the third mass weighed 11.87 ounces. The deflection will be measured using a dial indicator that would be zeroed in before each test. For each test, the wooden beam would have a ½ inch of overhang on the supports. The first scenario tested 2 beams bolted together with 95 thousandths of an inch diameter bolts. The holes were placed 2 inches from the outside edge of the beam. The second scenario tested 2 beams glued together using wood glue, and the third scenario tested the 2 beams without any fasteners being used on them. The first tests were conducted on 2 beams bolted together 2 inches from each of the outer edges. The first weight added was 11.47 ounces and caused 0.0046 inches of deflection. The second weight of 12.09 ounces was added, causing 0.009 inches of deflection. And the third weight of 11.87 ounces was added, causing the final deflection of 0.0149 inches. The second set of tests were conducted on 2 beams glued together with wood glue. The first mass of 11.47 ounces created 0.003 inches of deflection. The second mass of 12.09 ounces created 0.009 inches of deflection, and the third mass of 11.87 ounces created 0.015 inches of deflection. The third set of tests were conducted on 2 beams that were simply stacked upon each other. The first mass of 11.47 ounces created 0.0071 inches of deflection. The second mass of 12.09 ounces created 0.0188 inches of deflection. And the third mass of 11.87 ounces created 0.029 inches of deflection. At the beginning of this experiment, I thought that the beams glued together would have the least amount of deflection. I used data from the 3 tests to create a deflection versus load graph so that I could then compare the deflections of each test to each other. The gray trend line was the glue test, the orange trend line was the bolts test, and the blue trend line was the nothing test. From the data, we can see that the glued beams ended up having the least amount of deflection out of all the tests. I attempted to do some theoretical calculations to compare theoretical to actual data, but I ran into some troubles in obtaining the correct numbers for the theoretical data. In order to calculate the theoretical deflection, I used the simply supported deflection superposition found in the appendix A23. The equation for deflection that goes along with this position is y equals negative p times L raised to the third over 48e times I. Since I didn't know exactly what kind of plywood I was working with, I had to simply make an educated guess and use that guess to find the elastic modulus online, which I couldn't really find a good number for. So I just used the Southern Pine number 1 elastic modulus found in the back of the book. But this created some crazy numbers from the calculations that are way off from what I actually got in the tests.